Hi guys, this is O-level chemistry paper 2 specimen 2023 question 1. Choose from the list of oxides to answer the questions. Each oxide can be used once, more than once or not at all. So the list is given on our left. Identify which oxide has a giant covalent structure. In other words, which one is a macromolecule. So let's go over the list. Calcium oxide, this is an ionic compound. Carbon dioxide is a covalent compound, a simple covalent compound. Copper 2 oxide is again an ionic compound. Silicon 4 oxide or SiO2. This is a covalent macromolecule. So this should be our answer. So has a giant covalent structure, silicon 4 oxide. Okay. Part B. Reacts with acids with alkalis. Okay. So should be amphoteric. So calcium oxide, no, it's basic. Carbon dioxide is acidic. Copper 2 oxide is not the answer. Silicon 4 oxide is acidic. Sodium oxide is basic. Sulfur dioxide is acidic. Sulfur trioxide acidic. Zinc oxide. Zinc oxide is amphoteric. It will react with both acids as well as bases. So answer for part B is zinc oxide. Part C is used in flue gas desulfurization. So, flue gas desulfurization is a process in which sulfur dioxide reacts with a calcium salt. It should be calcium oxide or calcium carbonate. So, when it reacts with calcium oxide, it forms calcium sulfite, sulfite, CaSO3. And if it reacts with calcium carbonate, it again forms calcium sulfide and it releases carbon dioxide. So the answer is either calcium oxide or calcium carbonate. In this list, the first compound given is calcium oxide. So that is our answer to part C. Calcium oxide. Part D contains a cation with a charge of +1. Okay. So calcium oxide has a Ca2 positive ion. Carbon dioxide is not ionic. Copper 2 oxide, the number 2 written here states that the charge of the copper ion is +2. Silicon 4 oxide is a covalent compound. Sodium oxide. Sodium oxide has sodium with a charge of +1. So this should be our answer. So contains a cation with a charge of +1. Sodium oxide. Question 2. Atoms and ions contain protons, neutrons, and electrons. Complete table 2.1. Okay, table 2.1 requires us to put in the relative charge and the relative mass of a proton, neutron, and electron. So let's put the relative charges first. A proton is positively charged, so +1. A neutron does not carry a charge, so 0. And an electron is negatively charged, so -1. Now, the relative masses. A proton and a neutron are almost of equal mass. So, if a neutron has a relative mass of 1, a proton will also have a relative mass of 1. Whereas an electron has a much lesser mass. So, its mass will be given in as a ratio of 1 upon 1840. This is the relative mass of an electron compared to the relative masses of either proton or neutron. Next, part B says table 2.2 shows some information about 6 particles. So their number of protons, number of neutrons, and number of electrons have been given. Part 1 asks us deduce the nucleon number of particle A. A nucleon number is the number of protons plus number of neutrons. So in the case of particle A, number of protons is 37 and the number of neutrons is 48. When we add these two numbers together, we end up with a value of 85. Explain why particle B is a negative ion. So in order for a particle to be a negative ion, it must have additional electrons present in comparison to the number of protons, because the number of protons and electrons in an atom will be the same. So in the case of particle B, it has got 54 electrons and it has got 53 protons, which means it has one additional electron, making it an anion or a negative ion. Next, part B continues with its third portion. Identify two atoms that are isotopes of the same element. And we need to explain our answer. So, what is an isotope? An isotope is an atom of the same element having the same number of electrons and protons, but different number of neutrons. So, same number of electrons and protons. So, we have particles. A has 37 electrons, 37 protons, but 48 neutrons. Particle B has 53 protons and 54 electrons. Particle C has 92 protons, 92 electrons. Particle D has 92 protons and 89 electrons. Particle E has 92 protons and 92 electrons. Here we can see that particle C and particle E both have the same number of electrons and protons. So 92 protons here, 92 protons here, 92 electrons here, and 92 electrons here. And they should have a different number of neutrons. So 143 neutrons for particle C, whereas 146 for particle E. So particle C and E are isotopes of each other. And the explanation is the definition of isotopes. Both particles have the same number of electrons and protons, but different number of neutrons, making particle C and E isotopes. Question 3. Salts can be prepared by the reaction of acids with bases or alkalis and also by precipitation reaction. Okay. Part A, state the ionic equation for the reaction between an acid and an alkali. Okay, now we have different acids reacting with different alkalis, but what is common in them is that acid provides H positive ions, while alkalis or bases provide OH negative ions. And the H positive ion from an acid combined with the OH negative ion from a base, forming a molecule of water. This is the common reaction taking place between all acids and bases. So this will be the ionic equation here. Part B. Sodium sulfate is a soluble salt prepared by a titration method using an acid and an alkali. Identify the acid and the alkali used to prepare sodium sulfate. So we need to recall that sodium sulfate, the cation portion of the salt comes from the base, while the anion portion of the salt comes from the acid. So the acid that contains SO4 is called sulfuric acid, having a formula of H2SO4, while a base containing sodium ions is called sodium hydroxide, having a formula of NaOH. Part C. Aqueous sodium sulfate is used to prepare barium sulfate in a precipitation reaction. So barium ions react with sulfate ions forming barium sulfate. In an experiment, 20 cm cube of 0.55 mole per dm cube barium nitrate is added to an excess of sodium. So sodium sulfate is in excess. So the quantity of barium sulfate produced would depend on this barium nitrate. State the color of the precipitate formed in this reaction. So the color of barium sulfate is white. Next, calculate the maximum mass of barium sulfate that could be made, and they have given the MR of barium sulfate. Show your working. So the first thing we need to do is we need to calculate the number of moles of barium ions that react with sodium sulfate. So the concentration given is 0.550. So we have 0.550 moles of barium ions reacting with sodium sulfate. So, and the concentration being 0.550 mole per dm cube, 1 dm cube is equal to 1000 cm cube. So, we have 0.550 moles present in 1000 cm cube, out of which we have only taken 20 cm cube. So, we need to find out the number of moles in 20 cm cube. This would be 20 upon 1000 into 0.550, which will give us a value of 0.011 moles. So now we have found out the moles of barium nitrate that react, which is equal to the moles of barium that react. Now what we will need to do is we will need to calculate the mass. So the formula that incorporates mass, moles, and MR is N equals M upon MR. The MR is given here and the number of moles have been calculated over here. We need to find out the mass. So making mass the subject of the formula, mass equals moles into MR, which will give us 0.011 multiplied by 233, and the value of mass that we obtain is 2.563 grams. So the amount of barium sulfate that is produced in this reaction is 2.563 grams. Next, a mass of 1.92 grams of dry barium sulfate is obtained. Calculate the percentage yield of barium sulfate. Okay, so we just found out that 2.563 grams of barium sulfate are produced, whereas this part states that only 1.92 grams of dry barium sulfate was obtained. So out of the 2.563 grams, only 1.92 grams were obtained. So they're asking us to calculate the percentage yield. So the amount obtained will be in the numerator upon the total amount that should have been obtained would be in the denominator, and we will multiply this value by 100, and this will give us a percentage of 74.91. So percentage yield of barium sulfate is 74.91%. Question 4. Calcium chloride is an ionic compound. Deduce the electronic configuration of each of these ions in calcium chloride. So looking at the periodic table, calcium belongs to period 4. That means it has got 4 shells. But in its outermost shell, calcium has 2 electrons which it loses to form the Ca2 positive ion. So the outermost shell becomes empty, and now the calcium 2 positive ion only has 3 complete shells. So the electronic configuration of calcium would be, for the first shell, it would contain 2 electrons. In the second shell, it would contain 8 electrons. And in the third shell, it would contain 8 electrons. Now, moving on to the chloride ion. Calcium belongs to the third period, so it has got 3 shells present. And it belongs to group 7. That means its outermost shell has 7 electrons. Now, when calcium will be losing its 2 electrons, 2 chloride ions will combine with it to form calcium chloride. Each chloride ion will gain one of the electrons lost by the Ca2 positive ion, thereby obtaining a negative charge. And because chlorine belonged to group 7, it had 7 outermost electrons. By gaining an additional electron, it has 8 electrons in its outermost third shell. So the electronic configuration for chloride ion will also be 2 in the first shell, 8 in the second shell, and 8 electrons in the third shell. So the electronic configuration of calcium ion and chloride ion is the same. Part B. When molten calcium chloride is electrolyzed with inert electrodes, calcium and chlorine are formed. Construct ionic half equations for the two electrode reactions. So reaction at the negative electrode. Negative electrode is the cathode, and cathode is where reduction takes place. So the Ca2 positive ions present are reduced here. How are they reduced? They gain electrons. Where do these electrons come from? They come from the anode where oxidation occurs. So Ca2 positive plus 2 electrons gives us calcium metal, and reaction at the positive electrode, which is called the anode, we would have 2 moles of chloride ions because they were attached to the calcium ions via electrostatic attraction, which is the ionic bond. Both of them will be losing 1 electron each. So by losing 1 electron each, they would form chlorine gas, and the 2 electrons combined that were lost by the two chloride ions would be gained by the calcium 2 positive ion, which then converts to calcium at the cathode. Next, see, the electrolysis of concentrated aqueous calcium chloride with inert electrodes is similar to that of concentrated aqueous sodium chloride. Okay. Predict the products of the electrolysis of concentrated aqueous calcium chloride with inert electrode. Now, here we have concentrated but aqueous. Aqueous means water is also present. So, if we have water present now, there would be a competition for the release at the cathode for calcium and hydrogen from water. So since calcium is more reactive than hydrogen, so the substance that would be liberated at the cathode would be hydrogen. So H2 gas is liberated at the cathode, whereas we have a concentrated solution of a chloride. Whenever we have chloride ions present in excess in our solution, the product released at the anode would be chlorine gas. Next, part D, calcium chloride has a high melting point. Explain why calcium chloride has a high melting point. Use ideas about structure and bonding. So the structure for calcium chloride is a giant lattice. So we would write calcium chloride has a giant lattice structure in which strong ionic bonds are present between the Ca2 positive ion and two Cl negative ions. So this ionic bond, also known as the electrostatic force of attraction, this holds the cation and the anions in a solid lattice arrangement, which is also a giant lattice, and hence we have described the structure and bonding in CaCl2. Question 5. Figure 5.1 shows the alcohols ethanol and butane 1-ol. Describe the manufacture of ethanol from ethene. So here we have ethene, which will react with steam, and the conditions required for this reaction are in the presence of an acid catalyst, and this acid catalyst is basically phosphoric acid H3PO4 at 60 atmospheric pressure and 300 degrees Celsius. These are the conditions required for ethene to react with steam, and this results in the formation of ethanol. So we will complete our sentence: to form ethanol. So this is how the manufacture of ethanol from ethene occurs. Part B. Ethanol is used as a fuel. State one other use of ethanol. It is an alcohol, so it is used as a solvent. And also, since they've asked ethanol specifically, we can also mention the manufacture of vinegar, which is ethanoic acid. Next, construct a symbol equation to show the incomplete combustion of ethanol. Now we have got two possibilities. One, we would have carbon depositing, or we can have carbon monoxide forming. So let's write both the equations. In the case of carbon monoxide formation, we would have C2H5OH reacting with 2 moles of oxygen, giving us 2 moles of carbon monoxide and 3 moles of water. Whereas in the case of soot depositing, we would have C2H5OH reacting with only 1 mole of oxygen, because carbon will not be combining with oxygen, so we will have 2 moles of carbon being deposited and 3 moles of water being produced. So either of these two equations would be acceptable as the answer for this part. Next, ethanol is oxidized to form ethanoic acid. State the name of a reagent that is used for this oxidation. So, oxidation of alcohol to produce carboxylic acid. We need acidified potassium manganate 7. And the formula for potassium manganate 7 is KMnO4. Next, part D. Draw the displayed formula of a different alcohol that is an isomer of butane-1-ol. So butane-1-ol has the OH group present on the first carbon atom. If we move the OH group to the second carbon atom, we would end up with butane-2-ol. So let's draw butane-2-ol. So we have 4 carbon atoms present, 1, 2, 3, and 4. And like I said, we move the OH group to the second carbon atom. So all the other positions in this compound would be occupied by hydrogen atoms. And this is the structure of butane to all that we have just drawn here. So butane to all, which is an isomer of butane-1-ol. Isomers basically have different structures but the same molecular formula. So the molecular formula of butane-1-ol and butane-2-ol is exactly the same, but butane-2-ol has the OH group present on its second carbon atom, whereas butane-1-ol had the OH group present on its first carbon atom. Part E. Butane-1-ol is heated with concentrated sulfuric acid, which acts as a catalyst. But1ene and one other compound are formed. Okay, so basically, a dehydration of alcohol is taking place. So butane-1-ol is converted to but1ene, so water is removed. And they have asked us to draw the structural formula of but1ene. But1ene shows that the double bond is present on the first carbon atom, so we draw it like this. And there are 4 carbon atoms. So we complete the structure by adding the remaining hydrogen atoms to the structure of but1ene. This is it. This is the structure of but1ene. And they've also asked in the second part, reduce the other compound formed in this reaction. And like we had already discussed, butane-1-ol undergoes dehydration to form but1ene, in which a water molecule is removed. Part F. But2ene is polymerized to give polybutene. Okay. State the type of polymerization that occurs. Now, if the monomer but2ene contains a double bond and the polymer is formed, so the double bond opens up. When the double bond opens up, the kind of polymerization that is occurring is called addition polymerization. Okay. So draw the structure of polybutene showing at least one repeat unit. Polybutene has the double bond opened up. So we've got carbon and carbon where the double bond was present as a single bond. And if you look at the structure of butene, we have got one hydrogen and one CH on the carbon on the left. So one hydrogen and one CH3. And we have got one hydrogen and one CH3 on the carbon atom on the right. So one hydrogen and one CH3. And they've asked us to show at least one repeat unit. So this is one repeat unit. How do we complete the structure? We make brackets here showing that these bonds are extending, and we write N here showing that there are multiple number of repeat units in the polymer chain. Question 6. A mixture of ethanoic acid, ethene, and oxygen is passed over a catalyst at 200 degrees Celsius to manufacture ethynyl ethanoate, and the reaction is given over here. This reaction is exothermic. Okay. Draw a reaction pathway diagram for the reaction on figure 6.1. This axis that they have given us. On your diagram, label the axis. Okay, the reactants and products, the enthalpy change of reaction, and the activation energy. Okay, so first of all, they have told us that this is an exothermic reaction. An exothermic reaction is the one in which energy is given off. So in this case, we have got reactants at a higher level compared to the products. So we will write reactants here and we will write products here. The next thing that we will do is we will label the axis. The y-axis is called energy and the x-axis is labeled as progress of reaction. Okay, now what we will do is we will label the parts of the diagram in which we will be able to show the enthalpy change that takes place and the activation energy. So first the enthalpy change. The enthalpy change is the difference between the energies of the reactants and products. So we will write enthalpy change between these two dotted lines. And since energy is given off, the arrow will be pointing downwards. This is the enthalpy change, which is represented as delta H. Next, we have to label the activation energy. Activation energy is the energy difference from the reactants till the highest value in the energy profile diagram. This is the dotted line for the highest energy value, and activation energy is always positive, so the arrow will be pointed upwards from the reactants till the maximum point of energy, and we will label this as activation energy. So now our diagram is complete. In part B, they have asked us to explain why the enthalpy change of the reaction is exothermic. Okay, use ideas about bond breaking and bond making. So we have the bonds of the reactants being broken, right? Bonds of the reactants are broken. This is an endothermic process. We have bonds of the products being formed. This is an exothermic process because bond breaking requires energy and bond making releases energy. So bonds of the reactants are broken, so energy is required, and bonds of the products are formed, so energy is given off. Now, what we will do is it asks us explain why the enthalpy change of reaction is exothermic. So we have got an endothermic process and an exothermic process taking place. If the overall reaction is exothermic, that means more energy is being released than is taken in. So that is why the overall enthalpy change is exothermic. So we will write more energy is released during the reaction than it is absorbed, making the whole process exothermic. And that is why the entire reaction is exothermic, because the amount of energy that was released is greater than the amount of energy that was absorbed during this reaction.